examples. Probably won't have time for a demonstration, but I may show some screenshots of some example code that I'm making available. And we'll talk a little bit about where this module may be going in the future. So we'll start with CAN bus. It stands for Controller Area Network Bus. It's a bus standard that allows things like microcontrollers and other devices to communicate with each other in a system without a single well-defined host computer. It's a serial bus. You can have multiple masters, and everything's connected together through a single two-wire bus. And as we'll see, it's a message-based protocol. And most of this came from the automotive industry, but it's now being used in a lot of other industries as well. So it was originally developed by the company Bosch, and it's now been standardized as a series of ISO standards. So in your typical automobile, you could have as many as 70 CAN bus devices throughout the vehicle. So it's widely used in vehicle systems, but it's also being used for a number of other applications in embedded systems, industrial applications, different types of medical devices, in fact. I've even seen it used in some high-end bicycles. So we won't get into all of the technical details of the protocol, but it's a multi-master serial bus with multiple nodes. You need at least 2 nodes on the network to communicate. And the different nodes can really vary in complexity from very simple devices to more complex things like host computers. There's even possibility for things like gateways to other protocols like USB or Ethernet. So typically everything on the same bus is connected through a 2-wire bus over a twisted pair. It's designed for vehicle type environments, and the bit rates are up to about a megabit per second within 40-meter size limit, which is fully acceptable within something like a vehicle. So CAN bus is very common. It's almost certainly in your automobile. All consumer vehicles made since 1996 in North America have got a connector called an OBD-II, or onboard diagnostics connector. You may or may not have seen this. There's typically a connector that looks something like this under the dashboard. And since 2008 in North America, one of the protocols that you get access to is the CAN bus on your vehicle. So if you want, you can actually look at CAN bus messages in your car. There's a number of low-cost devices or interfaces that can plug into this OBD-II connector and gate that, interface that into a USB bus or serial or Bluetooth, and let you see what's happening on the CAN bus and even inject CAN bus messages. So there's actually a whole hobbyist movement of people who are into what they call car hacking, to reverse engineer some of the CAN bus messages in cars, understand how they work. This is really hacking in the original sense of the word, meaning that people want to understand more about how things work internally and maybe modify them, make them do things that they weren't originally designed to do. There's also people who work doing security audits of vehicles to try and make them less vulnerable to different types of attacks. So that's CAN bus. We'll get back to that when we talk about the Qt APIs. The other bus supported by the Qt serial bus module is Modbus. This is another serial protocol that's used for connecting different types of devices, more industrial type of devices. And like CAN bus, it lets you have multiple devices connect together on the same network. This came from a company called Modicon, which is where the name Modbus came from, going back to the late 70s when they were using things like PLCs. So it transmits information over serial lines between different types of devices. A bit of terminology. The device requesting the information is called the Modbus master, and the devices returning the information back are called slaves. And in a typical network, there's one master and multiple slaves, and everything has a unique address. And the data is sent in frames that are composed of different units, some of which I've shown here. So you have something they call an application data unit, or ADU, and it's made up of a protocol data unit, or PDU, and there's addressing information and error checking. So everything has a unique device on the bus. In the serial form of the protocol, then the only device that can initiate commands is the master, but this can also work in an Ethernet type of environment where you again have multiple masters. So some of the terminology goes back to the original use where typically they were driving relays and looking at the status of different types of measurement contacts. So you'll see references to things like a single bit output they'll call a coil, which originally was a relay coil. The single bit inputs are often called contacts. And so you have things like coils that are 1-bit controls that you can turn on and off. You have single bit discrete inputs that are readable. And you've got input registers that are 16-bit registers that you can read, and you have something called holding registers that are readable and writable 16-bit registers. So this is typically done over either serial ports, which can be things like RS-232 or some of the other variants like RS-422 and 485, or it can be done over Ethernet, typically using TCP port 502. So let's talk a bit about the Qt serial bus module that supports this. This was introduced in Qt 5.6 as a tech preview. In Qt 5.7, it's still tech preview, which, as you may know, means that the APIs can still change slightly in subsequent releases, so they're not yet considered frozen in terms of binary compatibility. It is planned to be final in Qt 5.8, which is getting close to release. We're just close to beta for 5.8. It's licensed like most of the other Qt modules, multiple licenses, either LGPL, GPL, or commercial. And the source code is all publicly available on QtIO's Git repository. It's maintained by a couple of guys from the Qt company. One note, it could be, you don't want to confuse this with the Qt serial port module that's been around since about Qt 5.1, and that's for RS-232 type serial interfaces. That's a separate module. So what are some of the platforms supported? On CAN bus, it makes use of plugins for the back ends, and there's different plugins for the different interfaces. Currently supports backends called Socket CAN, which supports Linux sockets and is Linux only. Peak CAN, which supports some adapters from a company called Peak System. Tiny CAN, which supports hardware adapters from a company called MHS Electronic, and Vector CAN, which are adapters from a company called Vector. For Modbus, essentially supports anything where Qt supports the underlying serial hardware, so anything supported by the Qt serial port module, as well as any networking devices. So it supports there any of the platforms, any of the hardware where Qt supports networking or serial. And in fact, it uses the underlying Qt serial port and networking APIs in Qt. So there's really two flavors. You'll see references to this moving up. RTU is what they call the serial version of this, and TCP is the Ethernet-based one. So looking at the Qt APIs, it's a set of C++ APIs or classes only. There's no QML bindings. It's not really a good fit for QML because it's more low-level code, not user interface code. So the information I'm going to talk about here, as I mentioned, there's still a tech preview, but this reflects the Qt 5.8 release, which should be considered final. So to use the module from your QMake project, you need to add the serial bus module, and there's a module level include file Qt serial bus, as well as the includes that correspond to each of the classes. So for CAN bus, there are 6 major classes here that I've listed that are pretty straightforward, and we'll talk a little bit more about these as I get into some example code. For Modbus, it's a little more complex type of bus. There's 14 classes provided, And I'll show a diagram later, but this supports both the client and server side as well as the serial and the Ethernet flavors. So this is where I was going to talk about all the methods provided by these 20 classes, but we've got 13 minutes left, so I'm not going to try and go through all of the method level, but we'll look at a few code examples. So I'll kind of show you some high-level examples of code and point you to some larger examples that I've written that you can download later, and I'll give a link to that. So for CAN bus, there's a number of steps you have to go through. They're pretty straightforward. You need to create a device, specifying the backend plugin that you want to use and the device name. Then you need to connect, and then you can start creating data frames with the data payload that you want and send them. And then when you're done, disconnect. Connect isn't really doing anything more than opening the device. There isn't really anything you're connecting to because of the it's a peer-to-peer protocol. So I don't know how readable this is. There's a kind of a high level of what you want to do. You need to create a device, and that's done with a static method that's basically a singleton that lets you create a CAN bus device specifying the backend that you want and the device name. And then the next step would be to actually connect. Now this example is sort of written procedural, but you really need to make it event driven. So this isn't really a complete runnable example. You need to make your code a little more event driven and work with signals and slots. For example, the connect here is something's going to happen asynchronously and happen sometime after the call. So continuing our kind of a high-level example, you would typically create a data frame of type QCAN bus frame with your data payload. So I've just got some sample character data here, but a lot of the effort typically would be in your application would be figuring out exactly what type of data you want to send and receive. And then once you've got that assembled, you can send it with the write frame method. And if you're finished with the interface, you can disconnect. So this isn't really a complete code example. You need an event loop. And I've got a larger example that you can download that will run as a full application and actually work. So we'll get back to that later with a screenshot. So on Linux, if you don't have an actual CAN bus hardware, there's a virtual CAN driver available that the Linux kernel can provide, and that's quite useful. There's a module you can load, a kernel module, and you can then create a virtual CAN bus device that you can use without requiring any real hardware. So I've listed here some of the commands that you can run to set that up. That can be useful for experimenting and simulation purposes. So my more complete example, which you can download, I'll give a link at the end, looks a bit like this. So I took basically the code that you saw, but put a little application around it and hooked it up to some buttons so that you could test connecting, sending some data, disconnecting, and it uses the virtual device on Linux. So moving on to Modbus. It's somewhat similar, except rather than being peer-to-peer, there's a concept of servers and clients. So you need to keep that in mind. The client sends the requests and gets responses back from servers. The terminology can be a little bit confusing because there's a single client and multiple servers. Sometimes they're called masters and slaves. So as I mentioned, there's support for serial devices and TCP-based network devices. One note on Linux, if you're using the default TCP port, which is 502, that's what's called a privileged port, which only root can normally run. So you either would need to run as root, or you might want to use a non-privileged port, which would be anything port 1024 or higher. So we'll look at a simple example of Modbus. This picture here is sort of an inheritance hierarchy of the Modbus classes that makes a bit more sense of them. So All of these classes derive from QObject, and below that you have a QModbus device, and then you have the two different flavors of client and server inheriting from QModbus device, and then at the bottom you have both the serial versions and the TCP networking versions. So typically you use the bottom level classes, but they share a lot of the APIs from the classes that they inherit from. So for Modbus, the basic steps are you need to create, in this case I'm going to create a client and a TCP client. The others are similar. So you need to create an instance of a QModbus TCP client. Then you typically want to set some of the connection parameters, and then connect using the method connect device. And then once you've got a connection, then you can start sending requests out for the different types of units that are supported by your hardware. So you may be sending requests to read or write or both for various devices. And then when you're done, you can call disconnect device. So at a high level, kind of a sketch of what you need to do. At the code level, we need to create, in this case, a QModbus TCP client. So we call a method to do that. And in this case, I wanted to use a different port. I wanted to use a non-privileged port. So we can call set connection parameters to specify the TCP port 1502, so that we use a non-privileged port. And then we need to connect. And in this case, you are actually connecting to the server on the network. So the connecting is something that will either succeed or fail. And then typically create some packets with some data information. So here I've created an ADU, which is part of the packet, and then sending a request out with that packet to ask a device to read a device for me and return the information back. So I'm calling send read request. And then when I'm done, I can call disconnect device. So like the Modbus example, this really needs to be event driven. You need to have an application, and the transitions from the different states, like connecting to being actually connected, are things that have to be done with an event loop. So I've created another example which you can download if you're interested, that has a little GUI around it, like the example for CAN bus. Just has a little main window and hooks up some of these actions to buttons so that you can connect, send a simple packet, and disconnect from the server. So I'll give a link later to that if you want to look at the code. To test it, you need a server or slave to connect to, and that's one of the examples that the Qt serial bus module provides. So you can run this with that example Modbus slave application. So the full documentation is available from within Qt Assistant, and is complete. It's pretty stable. It's been there for a few releases, so the 20 or so classes are quite well documented. So you can read all the details there. The Qt serial bus module also comes with some examples. So there's a CAN bus example, and there's 3 Modbus examples. You can find this typically in your Qt install under the examples serial bus folder. And I've shown some screenshots here of these graphical examples that are provided. You can run these on a Linux system. You can run the CAN bus examples with the virtual CAN bus device that I mentioned, so you don't need any hardware. In the Modbus examples, you can use a serial port or a TCP socket, so you don't need any really special software. So where's the module going in the future? In Qt 5.8, which is just coming up in the next month or so at the end of the year, the APIs should be considered final, so they'll be frozen, and they're going to maintain binary compatibility from that point on. We'll likely see support for more hardware backends, for maybe some more of the common controller boards. Another possibilities could be some other serial protocols might be added to the module. So a couple that just come to mind as possible serial protocols could be SPI and I2C that are commonly used on embedded systems. So that's a possibility, although those are kind of more real-time protocols that don't always run on the same processor as where you might be running the GUI. There have been some talk about rolling the Qt serial port module into this so that it's all one module. It's a possibility, but the Qt serial port is definitely going to stay there in order to maintain binary compatibility. So I think probably they won't roll the modules in together. There's not too much that they have in common. Other things that might happen, there are some higher level protocols that are used by Modbus and CAN bus. There's things like a standard called J1939, a standard for CAN called CAN Open, so there may be some work in providing more APIs for these high level protocols. And I'm sure there'll be some miscellaneous enhancements and improvements moving forward for things that people want to see. One example mentioned, I think, recently on the mailing list was having a way to enumerate all the CAN bus interfaces and see what their capabilities are. So wrapping things up, I guess one of the big strengths of Qt, as you probably know, is being able to write code that's portable across multiple platforms. We've seen kind of a trend of Qt historically moving kind of from a high level on the desktop, moving to lower in the stack, so that today we're seeing Qt running on embedded devices, and we're starting to see it support lower level devices and lower level protocols. So this kind of fits in with that trend of now giving you a cross-platform way to do low level serial bus programming. So as I mentioned, in Qt 5.8, the APIs should be considered final. There won't be a tech preview anymore, but there may be some enhancements coming in the future. So I've listed here a few references of things you can check out for more details, a couple of Wikipedia articles on the buses that are good starting points, the web-based documentation for the serial bus module, the Git repository, and a couple of the larger websites for Modbus and CAN bus. In the final link, you can download some of the sample code that I was talking about that has some more complete examples that will compile and run. So I've got just over a minute left. I can maybe take one question or so if we've got any questions from the audience.
Did you say you would support Lin?
Support what?
LinBus?
No, I think the ones I had in mind were SPI and I2C.
So Lin is not on the agenda?
I'm not one of the maintainers, so I couldn't really tell you if that's on the kind of on the roadmap, but certainly people are open to contribute other things to the module, support for more modules. I think part of the idea of the current one, it's a good starting point with the two most common buses, but some of it's going to depend on the community, what other interfaces people want to see. Yeah, question over here.
The SPI and I2C, how far do you think down the roadmap for those ones to have support?
I have no idea. That's just kind of a thought at the top of my head. What are some of the maybe the next most common interfaces? So it's hard to say. I think really it may depend on someone coming forward who wants to actually do it.
Is there any functionality or capability to write new hardware adapter plugins?
Yeah, for CAN bus, it uses plugins, so you can write new plugins and you can dynamically load those. So it's pretty similar to a lot of the other Qt modules. So nothing really special there, but you can write dynamic plugins. Yeah, I think that we're out of time, so thank you
Thank you very
everyone.
much, Jeff. ICS is a wonderful partner, so I encourage you to follow up with them. Thank you.